Next, we're going to discuss the three main laws of modern atomic theory. So keep in mind that a theory is made up of a lot of related scientific hypotheses or scientific laws. So that's why the modern atomic theory is made up of several scientific laws that are kind of combined together. So the first one is the law of conservation of mass, which states that in a chemical reaction, matter is neither created nor destroyed. So throughout this chemical reaction, the total mass of the reactants must be equal to the total mass of the products, which means that the mass of our starting material has to be equal to the mass of whatever we have left over at the end, which means that even though atoms are rearranging, they're not going to be just disappearing into the abyss. They have to go somewhere. So we can see this in this example of sodium and chlorine combining to form NaCl. So all of in this example, our sodium atoms are combining with the Cl2 molecules, and they're forming NaCl. In this particular example, all of our reactants are forming product, which is our final material at the end. But there are cases in which you do have some of your reactants left over, and we're going to look at those cases later on in the semester. But for now, just know that if you do have something that's left over, it's not going to just disappear. Your reactants are either going to not react, they'll stay in their original form, or they're going to form the product. But no matter what, matter is never created nor destroyed. It's only changed. We then have the law of definite proportions, which states that all samples of a given compound, regardless of their source or how they were prepared, have the same proportions of their constituent elements. Okay, so what does that mean? That's just your textbook definition of the law of definite proportions. But what that actually means is that the law, basically, the law of definite proportions talks about the proportions between the different types of atoms in a compound. So it's often called the law of constant composition because no matter where we get a certain type of molecule, it's always going to have the same composition. So let's take water, for example. We know that water is H2O. So let's say we have our H2O, and we'll draw that as an oxygen bonded to hydrogen. So that's our H2O atom. Imagine we have 18 grams of that. If we were to split that up into the individual hydrogen and oxygen atoms, then we would end up with 16 grams of oxygen and 2 grams of hydrogen for that total 18 grams of water. And then, if we were to look at the ratio of oxygen to hydrogen, it would always be an 8-to-1 mass ratio. So basically, this is a really kind of roundabout mathematical way of saying that a water molecule, or a molecule of H2O, is always going to have 2 hydrogens and 1 oxygen, no matter where it comes from, whether it comes from the ocean, whether it comes from your faucet, it's always going to be H2O, and that is going to give us our 8-to-1 oxygen to hydrogen ratio. We also have the law of multiple proportions. So this law was put forth by John Dalton, and we're going to talk about him a lot throughout the semester. A lot of his discoveries were really helped form the foundations of chemistry as we know it today, so he's going to come up a lot. But basically, his law of multiple proportions is that when two elements A and B form two compounds, and the mass of element B that combines with the 1 gram of element A can be expressed as a ratio of small whole numbers. What? So, here's what this actually means. Let's say that we have two different molecules. We have carbon dioxide, which is, that is 1 carbon and 2 oxygens. And then we have carbon monoxide, which is 1 carbon and 1 oxygen. So if we look at those ratios, the mass of oxygen that combines with, if we have 1 gram of carbon, that is going to result in 2.67 grams of oxygen. So that's just something that can be calculated once we learn how to figure out the masses of individual atoms, which is one of our upcoming lessons. In this next molecule, if we have 1 gram of carbon, then that is going to give us 1.33 grams of oxygen. So if we take the ratio between these two amounts of oxygen, notice that it is a 2-to-1 ratio. So, okay, like the math isn't too difficult to follow, but like what does that actually mean for molecules? Basically, what this law of multiple proportions is saying is that elements will always combine in whole number ratios. So whole number ratios, meaning that we're never going to see a molecule containing half of an atom. We're never going to see a molecule containing 1 carbon and 1/3 of an oxygen, for example. We're always going to have whole number ratios between the atoms in our molecules.